Hello everyone, and in this video today I am going to start VEX, Vector Expression Language. I will take you through VEX, and first I will tell you what is VEX and how we can use this VEX to create attributes and manipulate our geometry, how we can change things through VEX. From the last couple of days we have been using VOP nodes to create attributes and to modify them, but today we will do the same thing but by VEX. So I have already created a video with title, I guess, VEX and VOP, and in that video I have covered the very few basics of the VEX, but today I will also cover those basics and I will cover some new fundamentals of the VEX. This video would be very basic and it would be the starting of our VEX part of this series. So without wasting any time further, let's jump right on into the video. I have created a geometry container. Inside this, let's create first a sphere and toggle this on. We have a sphere. First, let's talk about VEX, Vector Expression Language. And what is this? It is Houdini's own programming language, and we can use this programming language to manipulate, control, modify, create our geometry, attributes, vectors, anything. Like anything. It's like the language which is working behind the scenes, but we can dive into that language and we can modify our scene, our geometry. And why do we use these codes? Why not just nodes? Because nodes only gives us a limited like control over our scene, over our geometry. But having this VEX, we can control like the fundamentals, the basics, the like everything from starting to the end of the geometry. We can manipulate it in like any way. We can modify vectors, matrix, points, edges, like anything. It gives us the freedom that nodes cannot give us. Right? So, what have we doing from the last couple of days? We were creating attributes through VOP. These VEX operators. So I have already talked about this and I already shared that this vector VEX operators, here we are writing VEX language but through nodes, right? When we started the VOP part, I have already talked about this, that we were writing the codes but through nodes. But in this video, we will write the codes ourselves. Okay, we were creating attributes through VOP, through our SOP nodes. And I want to do the same. Let's do it first, like the way we do. Attribute create. This is our SOP node, surface operators. This is used to create or modify the geometry, right? Okay, let's connect this here and toggle this on. We see we have attribute 1. We have attribute 1 and its value is 0. This node created an attribute and its value is 1. Its value is 0. Its name is attribute. We will give this new attribute and we will say SOP because we created it by SOP node. It is at the point class and its type is float. I will share everything, no need to worry. Okay, its value is 0. Let's say I want its value to be 1.1. Now we have an attribute, a new attribute. Its name is new attribute and its value is 1.1. Inside this, let's create another attribute. How we were creating this attribute? We need bind export this is to like output the values, right? These two nodes are same. We talked about it. So here we have our output node. This output node like outputs the values, the attributes we create. And let's create another attribute which is not here. This is our input node. Here from this node we can read our already existing attributes, but what if we want to create something that doesn't exist here? So we need, let's say, a constant, give this a value, and let's say connect this output, and this is what do we want to give this new attribute, and say VOP, because we created this, we are creating this by VOP nodes, and its type is float. I will share what are the different data types in a bit. No need to worry. And let's go here, and let's say we have now two new attributes. One is VOP and one is SOP. We created this attribute through SOP and we created this attribute through VOP nodes. Right? Okay. Let's create the same attribute but through VEX. First, I want to talk about some basics of the VEX. Let's create a node. I've already created some nodes for you, but let's create our new nodes. Here, let's say data types. Okay. What are the different data types we use in Houdini? First, we have worked with float. What is float? I've already talked about this. 1.1, 1.2, 1.3, 1.0. Any value which is in fraction. You see, these values are in fraction. So any value which is in fraction, which is in points, we can say fraction, points. These are similar because if two numbers are in fraction, their output would be in points. If I'm saying 1.0, this is equals to 1, but it is in point. So these values we say float. These are float values. We have integers. Integers are the whole numbers, 1, 2, 3, 4, 5, and so on, 10, 100. They cannot be in points. They cannot be in fraction. So if I'm saying, I will give one example. But for this, let's take an example. If I'm saying my data type is integer, and you are saying the value is 1.4. So what would happen? If you are saying my data type is integer, whole numbers 1, 2, 3, 4, and you are saying my value is 1.4, what it would do? It would round off this value and it would make it an integer. And how? If the value is below 1.5, it would round off that value to 1. So 1.4 will equal to 1. And if I'm saying 1.6, then it would be equal to 2. Right? 1.5 is like equals to 2. And you can say here we have float, integers, we have string. What is string? These are text like name, like example. We have created our new attribute. So this new attribute SOP is a string. It is a data type of string. This can be called as a string, but this is the name of the attribute. Here you need to understand something, and I will tell you in a bit. When we create our codes, we have string, we have vectors. Vectors are, we know, with values with direction, and vectors can have 1, 2, 3, 4 values, 2 values, 3 values, 4 values, but in general we say vectors have x, y, and z. It's a value with direction, and I have talked about this vectors a lot, but today's video, this is about VEX, so we will don't waste our time explaining these again. And now we know there are these data types and syntax. We have syntax. So what is this syntax now? Syntax is a way to write the codes so the computer can understand. There are some rules you must follow to write those codes so the computer can understand. There are ways to write those codes. And let's create our first attribute through VEX. So to have, we have to have some area to write the code, right? So to have that area, we have attribute wrangle, this attribute wrangle, and this is an SOP node because we are at the geometry level right now. When you connect this to sphere and toggle this on, hit P for its parameters, you have something like this, and this is our box where we write our code, and this runs over through points. So whatever we are doing here would be applied to points, would affect the points of this geometry. Let's create our attribute. We created our attribute through our SOP node, through our VOP node, and we will create the attribute through VEX. So to create the attribute, we have some terminologies you need to understand first. At the rate is for attribute, right? V, small v, not capital, is for vector, and these are our syntax. We cannot use the capital V to create our vector, vector attribute, because it's the way syntax rules. We have f float, I for integer, int for integer, float for integer, and I would use these. You can say float, but this float is we use this differently and we use this differently. I will show you in a bit. We need to create an attribute through VEX. We will say what we need to create. First, we need to tell this what we want to create. What is the data type first? We need to have the data type first. Let's say I want to create an integer data type. Value will be the whole number. So we can say I for integer and a for attribute. So I'm saying that I want to create I integer, an integer attribute, and after that we need to give this a name, new attribute, and equals. Now we need to give it a value 1, 2, 3, 4, 5, because it is an integer, not a float. So if you say 1.5, 1.3, and we have this semicolon, and this semicolon is used to end the code. So this semicolon is now telling Houdini that this code is end here, this code ends here. So we are doing this now. When I open the geometry spreadsheet, we see we have our new attribute, and we can say it's VEX because we created it through VEX. So we have something like this, and you see we have a little exclamation mark here, and it says implicit cast from float to integer. That means we are saying that the data type is integer, but we put the value 1.3, which is a float value. That's why it is now rounding off this value to 1. So let's put 1.5 so we can know what it is giving the output. What's the output of this? So when I'm giving this 1.5, we should see 1, because 1.5 round off 1. We are saying 1, but here you want to have this understand. You have to understand this. You have to understand this, that when I'm saying 1.8, it is giving us value 1. And why is that? Because this VEX expression language works like exactly. You cannot like play with this. In a way, you can play with the verb or the nodes. Here I'm saying the constant type, let's change to integer, okay? And I would, what if I give this 1.5? It is rounding off to 2. 1.4, it is rounding off to 1. Because this is rounding off, it can round off 1.7 into 2. It can round off 1.3 into 1. But here at the VEX expression, when I'm saying 1.2, it is rounding off to 1, which is good. But when I'm saying 1.7, it is also rounding off this to 1. So we have to put like an integer value to get the results we want, right? Okay. Now here I also want to tell you something. If you want to, this is like integer attribute value. We are saying the data type here is integer, but it is the attribute value. What I want to create a variable. The number can change. A number which can change. Here I am saying I want to create an integer, but you cannot say, like, you cannot write I to create a variable. You need to write integer to create a variable. What do you want this variable? Like, what do you want to call this variable? I want to call this variable. This is name. This is the data type, and we are saying I want to have the value of 5 and our semicolon to end this code. We see nothing. We see nothing because we have this variable. It lives here. This variable lives in this VEX expression tab. It is not an attribute, it's just a variable. Like this constant is a variable. We can change its value, and it doesn't live here, but it lives here, right? And same here, this variable lives here. And now we have this variable, right? And what I can say, I can create a new attribute, but this time float, and I will say new attribute, and I will say float, okay? And its value would be, let's say 1.2.5, okay? We see we have our new attribute float with value 2.5. And what I can say here, instead of this 2.5, I can write our variable name. So here our value is 5 because our variable value is 5, and you can change its value, and you see our variable value is now changed. It is changing. It is now this value. This new attribute float value is variable. This variable is equals to 6, right? Okay. Here I want to share something else. I want to tell you something. It's just syntax tool. You cannot give space here. It won't work because this attribute, this is the whole attribute. This works as a single quote. This is our whole attribute. It has attribute name, and attribute at the rate, which is attribute, and we have its data type, which is float. Also, I want to tell you something here, that if I'm saying let's create a vector cd at the rate c and d. Cd is for color diffuse, right? And you cannot type capital V to create a vector because it's just syntax. And we have v at the rate c d. Cd is for color, but you cannot type cd like small c and small d because color diffuse is capital C and D. We have the cd, and I want to name this color. I want to name this color, but it is not you cannot name this color because cd is already a name, because attribute cd, this is the whole attribute like this. We are saying it's a vector and it is an attribute and its name is cd, so we are putting the value into the cd. Cd is color diffuse. We don't have a cd because we haven't completed the code yet, so we need to complete. Cd is our color diffuse and its name is cd, not something else. And when we write a vector, we need to put these in curly braces, sorry. You need to put this vector value in these curly braces. You cannot put a a letter here because it needs a value, it needs a number. When I'm saying 1, 1 and 1, now we have something. What is this something? We have our cd values r, g and b. We have created a vector. Vector has this vector cd has 3 values, which is r, g and b. R, g and b are vector components, and you see we have this code. Now we can change the values. Now we would see red color because red channel is equals to 1. That means 1 positive and 0 means nothing. Its value is 0. So when we see 1, when we say 1 in red channel, 0 in G channel, green channel, and 0 in blue channel, that means we have only one channel working in, which is red. Its value is 1. So when you say 1 0 0, which means red. Okay. So we have created a cd attribute. What if I create another cd attribute? So which will work? This would work, or the new attribute we would create would work. We can say vector at the rate cd and equals to, what do you have the value now? 0, 1 and 0. Right, let's finish this code, and we have now green. I want to share something here. You cannot say cd. This created a vector. This created another vector by this name cd, and you open the geometry spreadsheet. Now you have this small c and small d. It is also a vector, but it is not color diffuse. Color diffuse is capital C and D. Let's make this capital. And what if I put here this variable name? inside this vector. Let's do that. Variable. It is not working. Why? Here, another important thing. These curly brackets means vector values. And vector values cannot be variables. It needs a specific value. You have to give this a specific value. The value that cannot be changed. It can be changed by putting a different value, but it cannot be a variable. Something like 2. It can work, but if you say I can give here a variable, so this variable value is dependent on this. If the value change here, if we change the value from here, the value would be like the same of this value. So this is a variable now and it cannot work because vector needs a specific value. Let's say 4. It can work now, right? Okay, what if I want to give this vector this variable? It cannot happen, but what you can do, if you want to like multiply this value which we were doing here, let's read our CD and let's say multiply. We have been doing this a lot. Multiply, and I want to read the CD value into the CD and this constant. Let's connect this into input 2. Now the values coming out from this CD has been multiplying by this constant, and we are outputting this value into the CD, right? Okay. Now we would see nothing because the integer is, let's say, a float value. We see nothing because the float default is 0. That means 0 multiplying by this value would equal to 0. 0 means black. And when I say 4, we have this color now. You can see the values here. All these channels have a value 4. But here you can do the same. And what you can do here is you can say I have CD equals to, what do you want to multiply? I want to multiply this variable, multiply star, and we have our 4. You can change the value if you want. Let's say 1, 0 and 1, right? Okay. Now we have this. So now this variable value, which is the 6 value, 6 is now multiplying with this value and we are getting this color. So I hope you understand till here, and if I want to like tell you something here also, we have 3 CD color diffuse values, right? So which value Houdini is reading, like which value has the dominance over which value. So this we are creating code from ascending to descending, right? And this value, and this value is overriding these two values. So this code is overwriting this code. If we have 3 series, so the most recent value of CD would overwrite every other value. We are seeing 6, 6. We have 6, 0, and 6 because 6 is multiplying by these values, and we see this color. Now, what if I want to like have a vector component, a variable? How can we write that in code? I've said that the code in the curly braces have to be a constant, have to be a number, a specific number. It cannot be a variable which can be like changed, which can change. You cannot put here like p dot y, because the values that are coming from y, it can change, right? So this curly braces needs a specific value. But what if I want to put variable in vector components? We can do it by, let's create another vector at the rate, let's create cd color diffuse. Okay, now to write this, we have this syntax: set bracket and your variable name and your values, and we can have something like this. What if I increase the value of this variable, let's say 10? We see something like this. What if I want to have this 0? We see something like this. So this variable is in these vector values, but when you are saying curly braces, you need to have a specific value. You cannot have a variable inside it. Let's create a vector, but this time let's say Pscale. I want to create an attribute Pscale. What if I want to change the Pscale values of these points, of these sphere points, and what if I want to copy some another geometry onto these points? What we can do, we can create attribute. What is the value, what is the data type of the Pscale we use? Pscale is not a vector, it's a value. We can have integer, we can have float, but let's say integer and Pscale scale. Okay, and let's say its value. What would be its value? Let's say 0.5, but it's an integer, we cannot say, so let's give this a float value and 0.5, because 0.5, and because if I give this a bigger value, then the copied geometry would be very big, we cannot see it. So let's copy our geometry. Let's create another sphere and copy 2 points. Let's copy this sphere onto these points, toggle this on, and we see something like this. And let's decrease the sphere size, its radius, so we can see our sphere. Now we have these spheres copied to these points, and we can we can scale those spheres according to this Pscale attribute. If I want to say I want to have these of scale 1 unit, you can say now these are scaled, right? Let's shade it. Okay, the variable value is too bright. Let's say 1. Okay, now we have these sphere copied to these points, and I can say that I want to have a variable value here instead of 1. You can write, let's create a variable first, let's say a float, and here you need to write the name float, and I want to say this value, right? And I want to say this let's say 1.4. Now we have a float value, it only lives here, not at the attribute. It's not an attribute, it's just a value. So let's say I want to give this value. Now we have this variable here, So when we change the variable value, I'm changing the Pscale value. Example here, right? Okay. I think the very basics of the VEX expression language has been covered, and I should finish this video here, right? Because this this is the very basics of the VEX, and we need to understand this first. I would say play with these values, play with these attributes, recreate these values, recreate your own attributes, change the p scale through this, and I have created some nodes, the same nodes. Yes. One another thing I want to share. You remember when we created group expression in the procedural tower, I guess. So I will show you something here, and it's really important. We created something like this. Okay, we created something like this, if you remember, and here we had these uh, circular rings, and uh, these are like separate rings, right? So they have been like separated, and we gave this class, we gave this connectivity, and we gave these each circular ring a class attribute. You see here, this is the class, and each ring has a class 1, 2, 3, 4, 5, 6, 7. So each parameters of this circular ring, the circular parameter ring, has class 0, and we have till here. So we promoted this to the detail level, and I have talked about these functions like in detail at on this like in that video, and we created this group expression. So what did this group expression do? So this group expression gives us the freedom to create group by the code, right? By vector expression language. And in that code we wrote at the rate class equals at the rate max, double equals at the rate max. And when we created our connectivity, when we promoted our class to the detail level, we were saying that the maximum value would be the number of the classes. I have already talked about that in that video. And here I want to like, if you are seeing this but you haven't watched that video, no need to worry, just understand this. These two equals means comparison. Again, these two equals means comparison. We are comparing attribute class values to the attribute max values. Here we are comparing, and here we are assigning the value. Here we are not comparing. Double equals mean comparing, and single equal means we are assigning the value. So I hope you understand. Just read these if you want. Syntax, I have wrote this here, and here we are assigning a value as I explained. Here we are comparing new attribute. Here new attribute is a string here, but this is the attribute name. This here new attribute is a type of string, it's a name, so it's a text I was saying, but this is the name of the attribute. So I guess this is it for the video, and I will see you in the next video. Until then, take care.